Dear students, welcome to Engineers Coaching. Today you will learn about lines and angles. And in this chapter we will study the topic when parallel lines are intersected by a transversal. In previous episode, we have studied about the basics of lines and angles. Now let's study the topic when two parallel lines are intersected by a transversal. These are two parallel lines, line L and line M, and these lines are intersected by a transversal T. When two parallel lines are intersected by a transversal T, then angles so formed are as follows. First of all, corresponding angles. In this figure, you see that angle 1 and angle 5. These are corresponding angles. Similarly, angle 4 and angle 8 are corresponding angles. And angle 2 and angle 6 are corresponding angles. Similarly, angle 3 and angle 7 are also corresponding angles. And we know that the pair of these corresponding angles is always equal. Means angle 1 is equal to angle 5. Means corresponding angles are always equal when two parallel lines are intersected by a transversal. Then angles so formed corresponding angles are always equal. I have written the same thing here. Now in this figure, angle 1 and angle 3, these are vertically opposite angles. Similarly, angle 2 and angle 4 are also vertically opposite angles. And angle 5 and angle 7 are vertically opposite. Similarly, angle 6 and angle 8 are also vertically opposite angles. And you have studied in previous episode that vertically opposite angles are always equal. Now we take angle 4 and angle 6. What is the relation in between these angles? Angle 4 and angle 6. Similarly, angle 3 and angle 5. What type of these angles are? These angles are called alternate interior angles. Angle 4 and angle 6 are alternate interior angles. Similarly, angle 3 and angle 5 are also alternate interior angles. Now also angle 1 and angle 7. These angles are called alternate exterior angles. And angle 2 and angle 8 are called also alternate exterior angles. So pair of these two angles is also equal, means angle 1 and angle 7 are equal and angle 2 and angle 8 are equal when two parallel lines are intersected by a transversal. Then alternate interior angles are also equal and alternate exterior angles are also equal. Now there is also a specification in this figure when two parallel lines are intersected by a transversal. Now what is the relation between angle 4 and angle 5 and angle 3 and angle 6? Angle 4 and angle 5 are interior angles on same side of transversal. This is transversal and in this side there is angle 4 and also to the same side this is angle 5. So angle 4 and angle 5 are called co-interior angles or alternate interior angles on the same side of transversal. These angles are also called conjunctive interior angles or co-interior angles or also called allied angles. So alternate interior angles on the same side of transversal are named as co-interior angles, conjective interior angles or allied angles. And there is a special thing of these angles, that these angles are always supplementary, means angle 4 and angle 5 which are on the same side of a transversal, their sum is 180. Similarly, angle 3 and angle 6, which are also on the same side of transversal, as you angle 3 and angle 6, these are also on the same side of transversal, and angle 4 and angle 5, these are also on the same side of transversal. So angle 4 plus angle 5 is equal to 180. Also angle 3 and plus angle 6 is equal to 180, means sum of these angles on the same side of transversal and interior angles, sum of these interior angles on the same side of transversal is 180. So these angles are called co-interior angles, or these angles are called supplementary angles because their sum is 180 degree. So the specification of alternate angle on the same side of transversal is that these angles are supplementary. Supplementary means the two angles whose sum is 180. Those angles are called supplementary angles. Now a theorem creates on this topic, that alternate anterior angles on the same side of transversal means co-interior angles are supplementary. So let's study this theorem. This theorem is prove that co-interior angles are supplementary when two parallel lines are intersected by a transversal. So what is given in this statement? The given thing is two parallel lines are intersected by a transversal. Take this figure. These two lines L and M are parallel lines and they are intersected by a transversal T. So angles on the same side of transversal are interior angles on the same side of transversal are angle 1 and angle 2. Also on the other side of this transversal, the interior angles are angle 3 and angle 4. Now we have to prove that angle 1 and angle 2 are supplementary, or angle 3 and angle 4 are also supplementary. So proceeding step by step, what is given? Two parallel lines are intersected by a transversal. Now we have to prove that angle 1 plus angle 2 is equal to 180. Angle 1 plus angle 2 is equal to 180 means angle 1 and angle 2 are supplementary angles. Similarly, angle 3 plus angle 4 is equal to 180 means we have to prove either angle 1 or 2 are supplementary or angle 3 and 4 are supplementary. So to prove this, we have to construct this figure. Construction: draw a line N parallel to T. In this figure, we have to draw a line. Which is parallel to this transversal T. Now I am drawing this line. I have drawn this line N. Which is parallel to which is parallel to T. Now angles, let this angle is equal to 5 and this angle is equal to 6. Now we are watching that this line L and this line M, L and this line M are parallel lines and T was transversal of these lines. We have drawn another line N which is parallel to T. So the figure constructed by these pair of two parallel lines intersecting each other, we name it as A. This point is B, C and D. So these two lines and these two lines which are parallel, so the pair of two parallel lines which construct this figure will be a parallelogram because opposite sides of this quadrilateral are parallel. So this is a parallelogram, means A, B, C, D is a parallelogram. Because when in parallelogram opposite sides are always parallel and equal. And there is also specification or there is also characteristics of parallelogram that opposite angles of parallelogram are always equal. Parallelogram has opposite angles equal. So A, B, C, D is a parallelogram and angle 1 and angle 6 are opposite angles. So these angles are all equal. Similarly, angle 2 and angle 5 are opposite angles of this parallelogram. So these two angles are also equal. This we will take in proof. Let as L parallel M given, this was given to us that line L and line M were parallel, and we have constructed another line N which is parallel to T, N parallel to T. This is by construction. Therefore ABCD is a parallelogram. ABCD, what is ABCD? ABCD is a parallelogram because its opposite sides are parallel. So angle 1 is equal to angle 6, angle 1 is equal to angle 6 and angle 2 is equal to angle 2 is equal to angle 5 because opposite angles of parallelogram are always equal. Now the property of quadrilateral is that the sum of interior angles of a quadrilateral is always 360, means angle 1 plus angle 2 plus angle 5 plus angle 6, sum of all these four angles is 360. This is the property of quadrilateral. So in figure ABCD or in quadrilateral ABCD or in parallelogram ABCD, angle 1 plus angle 2 plus angle 6 plus angle 5 is equal to 360, sum of interior angles of a quadrilateral. Now we have studied in the above line that angle 1 is equal to angle 6 because opposite sides of parallelogram, opposite angles of parallelogram, the interior angles are always equal. So angle 1 and angle 6 are interior and opposite angles in a parallelogram. So these angles are always equal. So we have written here angle 1 plus angle 2 plus angle 6 plus angle 5 is equal to 360, means sum of interior angles of this parallelogram. But angle 1 is equal to angle 6 and angle 2 is equal to angle 5. So placing angle 1 in the place of angle 6. So we have put angle 1 in place of angle 6 and angle 2 in place of angle 5, that is equal to 360. So this equation becomes angle 1 plus angle 2 plus angle 1 plus angle 2 is equal to 360 from 1, because we have considered this equation 1. Now angle 1 comes here 2 times, similarly angle 2 also comes here 2 times, means 2 into angle 1 plus 2, because both these angles have 2 times in the sum of this equation. So 2 into angle 1 plus 2 is equal to 360, which gives us angle 1 plus 2 is equal to 180, means angle 1 plus angle 2 is equal to 180. This was we have to prove, means angle 1 and angle 2 are angle supplementary. This was that we have to prove angle 1 and angle 2 are supplementary, means co-interior angles are supplementary, or alternate interior angles on the same sides of a transversal are always supplementary. Similarly, in the same way, we can prove that angle 3 and angle 4 are always supplementary, taking in this case another parallel line in this side. We can prove angle 3 and angle 4 are also supplementary angles. Similarly, I have written here, similarly we can prove angle 3 plus angle 4 is equal to 180. This implies co-interior angles are always supplementary when two parallel lines are intersected by a transversal. So we have studied today the topic when two parallel lines are intersected by a transversal, and the theorem generated by this property that co-interior angles are supplementary when two parallel lines are intersected by a transversal, means when two parallel lines are intersected by a transversal, then so formed co-interior angles are always supplementary. We have proved this theorem also, and I expect that you have learned or you have studied it carefully. Thanks for watching.